this section, we're going to install the Telnet server on our Red Hat Enterprise box. Telnet is a package included with Red Hat Enterprise 5, and here from our recent study, the enumeration of 1 million.txt using FTP. And we'll take a look at the repository here and do a search using Control F for Telnet, where we'll find two packages. One is the Telnet client, which is already installed by default, and the other is Telnet-server. From the shell, an RPM on either box, query all grep-i telnet, will reveal that the client package is installed momentarily. And ditto over on the remote system, which is a slightly newer version of Red Hat Enterprise. Let's go ahead and copy this command and try it on the remote system to see what the result is. It'll come back very quickly. And as we can see, only the client's installed. An RPM query list of that package reveals only the client and a man page. The Telnet client, as mentioned earlier, is used for testing connectivity to TCP ports, as well as for setting up sessions to systems that support Telnet, whether operating systems or infrastructure devices or any other type of device. So that said, let's set up a section and get it installed. The features include shell interface on remote system. So it's just like being on the remote system. However, one caveat of using Telnet is that it is a clear text-based application like FTP, which means credentials are transmitted in the clear. So credentials are transmitted in the clear, which means a man in the middle can intercept those credentials and gain unauthorized access to your system. However, it's very useful in that it allows you to run applications via a shell interface on a remote system. It essentially provides the shell feature provided by SSH. So wherever possible, use SSH instead of Telnet. But there are some applications that I've seen that work with Telnet and not with SSH, which is why you should at least know how to set it up and connect to it. So with that said, let's install it. The Telnet server, that is, by using yum with the Y option Telnet server. We'll install it on both systems and then examine the changes. Let's begin by installing it on our local system. We'll have to su in, of course, and then execute the yum y telnet-server, which will consult, and we missed the install option, which will consult the repository. Let's update our documentation to reflect install. And then return to the shell. So there we see Telnet's installed. In fact, on our local system, TelnetD was installed. Again, the default Red Hat Enterprise 5 installation does not include TelnetD, or does not install TelnetD unless you explicitly indicate during installation or indirectly by installing a program which depends upon it. So we should note, it's not necessarily a caveat, but it's a requirement, TelnetD, which is installed automatically via yum. So if you use yum, TelnetD will be installed. TelnetD is a super server which manages programs like Telnet. So essentially, TelnetD will set up a listener on the Telnet port 23, and whenever a request comes in for Telnet, TelnetD will launch an instance of Telnet-server. And we should just note as well that it binds to TCP 23. So with that said, let's examine the contents of the package using RPM query list Telnet-server. And as we see, there's an entry beneath TelnetD.d for Telnet. The main daemon itself located beneath user sbin. So when TelnetD executes, it listens to port 23 using the TCP protocol, and when a request comes in, it fires up an instance of user sbin in.telnet.d. And as usual, there's documentation. Let's navigate to etc zinetd.d, then nano the telnet file, where disable is set to yes. Most, if not all, zinetd entries are disabled by default. So to nano etc zinetd.d telnet, and then change disable equals yes to disable equals no. Then the third step will be to restart zinetd using service zinetd restart. And this affects changes to the zinetd superserver so that it begins listening on port 23 for inbound telnet access. So let's move forward, and here we're going to Control K, Control U, and comment out one line and change the other yes to no. So again, the socket type here instead of datagram is stream because it's TCP. It doesn't have to wait for packets from the same source because it's stream base, which means zinetd is free to launch as many instances of the TelnetD program as necessary. When zinetd executes this program, it will run as root. If there's a logon failure, zinetd will log the user ID. The superserver supports the logging of other variables. Just man zinetd and zinetd.com for more information. Let's save the changes, and then we'll execute service zinetd restart. And it wasn't running, so it failed to stop, but it did succeed with starting, which means now a netstat ntl grep23 should reveal a listener. However, if you append a p to the ntl option, you'll see that the zinetd program is listening to port 23, not the in.telnetd binary located beneath user sbin. So again, this is exactly what we expect, and now we'll be able to connect via a remote system. Now let's just list as a caveat, by default, root is not permitted access via telnet server for obvious reasons, so that you don't leak root's credentials. However, this is controlled via etc secure TTY. If you rename or add the TTYs allocated by telnet to the secure TTY, then root will be able to the file that is, then root will be able to log in. So a less of etc secure TTY will reveal TTYs that are considered to be secure. Notice there are no pseudo terminals defined. So you may be wondering, how is it that SSH works since it allocates pseudo terminals? SSH is an exception to the secure TTY files entries because SSH is inherently secure. So these consoles are considered to be secure. Root may log into these consoles or via SSH. So with that said, Telnet's running on our local system. How about ensuring that it's installed on the remote system? And we'll go ahead and yum it, have it installed. And we had the Y in memory without the install option. This will install it on the remote system as well, so we can telnet to and fro. And again, let's nano etc zinetd.d telnet, and Control K to cut, Control U twice. We'll disable one of them and set disable equals no. Then we'll execute service zinetd restart, and it was running, so it stopped, and now it's started again. And finally, nets.ntl grep23 reveals that it's listening. It's listening by default to all IP addresses, which can be controlled via zinetd, which we'll look at in the security section. So now we've got Telnet up and running on two systems. So what we need to do at this stage is connect to both systems from either system. So tasks include connect to both systems from either system using Telnet client. And to do so, we'll simply telnet space from the local system to the remote system 192.168.75.199. This will connect us to the remote system and provide us with a prompt. But again, be warned that the communications between the client and the server are conducted using clear text protocol, or using a clear text protocol. So, let's try to telnet into that remote system. And there's the prompt. By default, the telnet server reads the contents of etc issue, or /etc/issue. So note, by default, telnet server reads and displays the contents of etc issue, which includes what you see: Red Hat Enterprise Linux, the release, kernel with variables reflecting the version as well as the platform. So now to log in, let's indicate the credentials for a user, such as Linux CVT. And the session was closed. Let's try it again. It's because we took too long. So let's try it again. And now we have a telnet session to the remote system. We can determine the TTY by executing TTY. And this tells us that dev sudo terminal 1 was allocated. So let's also note, this will allocate a free sudo terminal if the user authenticates successfully. And just like SSH, Telnet relies upon PAM or Pluggable Authentications module to handle authentication. So it doesn't have its own built-in auth module. It simply references PAM, which consults the etc password and shadow files to determine whether or not the user who you claim to be is indeed the user who you should be in terms of username and passwords checking out. So we've been allocated sudo terminal number 1. Let's open another session to the remote system just to be sure that it allocates another sudo terminal. We'll do so from this Linux CVT shell, non-root shell, by telnetting again to 192.168. In fact, let's just show you that the socket's open, and nets that ANT will do just that. If we grab 23, you'll see that from the local system's IP address of 192.168.75.10 on a high port of 56,428, we have sourced an outbound established connection to 192.168.75.199, port 23, which is the telnet port. And that session is indeed established. That's this window over here that's connected to dev sudo terminal number 1. So whenever you source a connection to a remote system's TCP port, you should see, and if the session's up and running, a socket indicated with the established value in the state column. So this is an established session. Now, just before we move into creating the new connection, we should note that TCP UDP ports range from 0 through 65,535. So note, TCP as well as UDP ports are 16-bit based, or 2 to the 16, or 0 ports 0 through 65,535. So when you see high ports such as the one you see here, 56,428, know that you still have thousands of ports to go, or in other words, thousands of potential sessions to go before filling up all of the TCP slots. And this is the premise of how network address translation works. It maps connections outbound or inbound based on source or destination ports. And it allocates a unique port since each IP address has 65,536 ports per protocol, TCP and UDP. So in this case, our local kernel on this system has elected to pick this high port of 56,428. But because we've instructed the Telnet client to connect to a Telnet server, which it knows to be on port 23, it has to terminate us on port 23 on the remote system. So let's now open another socket. We'll telnet to 192.168.75.199 again. And we will then log in as Linux CVT. The prompt doesn't assume that we're a given user. It expects us to indicate who we are. And now we'll confirm the sudo terminal again. Notice also that the system registers the last login. This information is stored in the WTMP file that we discussed briefly earlier on, located in var log. So the WTMP file maintains entries for when and where a user has logged in from. And whenever you log in, the program responsible for handling logins will return last login information. So now we've been assigned sudo terminal number 3 on remote system. In this session again over here, we have sudo terminal number 1, so you may be wondering where's sudo terminal number 2. Well, if you recall, we've long had this SSH session open, and that's why sudo terminal number 2 was not assigned. If we were to drop the SSH session, and then drop the telnet session, and then reinitiate, let's say, instead of SSH, telnet, sudo terminal number 2 will be assigned providing we authenticate successfully. Let's go ahead, and now you see sudo terminal number 2. And if we try from the third window, it'll assign the next available sudo terminal, which is sudo terminal number 3. And again, a TTY will reveal as such. So the sudo terminals are assigned sequentially, in order, just as they are when using SSH. So by default, sudo terminals are assigned. Note, the PTYs are assigned sequentially by default. And by sequential we mean if you connect in one window as yourself to the remote system, but then one or more users beat you to the assignment of subsequent TTYs, you will then be assigned a TTY after those users have been assigned. So it's based on a first come, first serve basis. Now let's log off and try to connect as the user root. We'll indicate root's password, and it will not work. However, if we kill the session, which we'll do, or it'll time out momentarily, and on the remote system move that secure TTY file that we've mentioned, you'll see that it'll work. So as a separate task, and we'll get back to the first task of connecting to the source system momentarily, enable root login via telnet. To do so, again, we're going to move etc secure TTY or add new sudo terminals to the list, such as sudo terminals 1, 2, 3, but since the sudo terminals are assigned dynamically, we need to be careful that we don't restrict root access to specific TTYs, which is why it might make more sense to just simply move the etc secure TTY file. So if we move this file to etc secure TTY dot, let's say, disabled temporarily, this will do the trick on the remote system. Let's go ahead and find that shell, and we'll need to do so as root. So let's SSH as root. In fact, since we're using telnet, let's telnet as Linux CBT, and once over on the remote system as Linux CBT, we'll SU in. This will allow us to gain root access to the remote system. And again, the act of SUing in on the remote system transmits the user's password, or root's password, which can be captured and processed by any packet analyzer such as Ethereal/Wireshark. Now with that said, let's move etc secure TTY to secure TTY disable. That seems to have been moved properly. Let's just ensure by examining the contents of etc, and there it is. There's no longer a secure TTY file. If we try without the suffix, it'll fail, returning a non-zero exit status. So now the file's been moved. Now at this stage, we'll be able to log in as the user root with telnet from, let's say, the local system, authenticate as root, and then we'll authenticate, then kill the session using Control-C. Tried it again, and Control-C. So we've killed it. It threw an error anyway, no shell, permission denied, but we've gotten past the stage. We actually logged in. Last login, a certain timestamp from a certain server, we actually made it in. So it's working as expected, whereas if we move etc secure TTY disabled back to simply etc secure TTY and then try to log in again, we won't even get that far. So this time it doesn't let us in and reflect when we last logged in. So secure TTY works, and regarding the login shell, the login process ties into PAM, so we'd need to check into PAM to see why it's throwing an error, but at least let us log in, and we Control-C it anyway to kill up upon entry the login. So now, from the remote system, let's connect back to our local system using Telnet. And that'll be back to the 10 box, and there we see the shell, and it returns the full name, the kernel version, which we've upgraded to 53, and then we'll log in as Linux CBT. And let's try it again. We typed in the wrong password there. And we'll try it again. It'll kick us off because, again, PAM-related issues. But we should at least see the last login if we've authenticated correctly. And there we see it. And in fact, it's given us a session. Here we are on Linux CBT Serve 1. Who am I will tell us that, whereas we connected from Linux CBT Serve 4, but it did throw an error. It says cannot resolve network address for the KDC in requested realm while getting initial credentials. There are probably some configuration traces left over from previous editions of Linux CBT related to KDC that we have not cleaned up, causing Telnet to throw its error, but nonetheless we're in. On the remote system, TTY tells us we've been assigned sudo terminal 6. And if we log off, now we will be returned to serve 4. And we can try it again. Just wait for it to come up. And providing we have the right password, we're in. On remote system, TTY sudo terminal number 6. So Telnet works both ways, but again, it is a clear text protocol, so use it with caution, use it with care, use it when only necessary. And in some cases, it is actually necessary to use the clear text server. Wherever possible, use SSH in its place. So wherever and whenever possible, opt for SSH in place of Telnet. However, if it's not possible, then by all means there's nothing you can really do. Super, so we got Telnet up and running. There are no SE Linux implications. It's a service that's not suggested, but there are no errors. We're able to log in. Just note that you can't log in as the privileged user root unless you make secure TTY changes, which are non-standard. So generally you'll use Telnet as a non-privileged user no differently than you would with FTP. FTP works similarly by controlling who may log in via etc FTP users. So the same can be said for the local system, and let's just confirm it on a VSFTP directory, that is, since things have been moved there. So just like with VSFTPD, where there's a list of users who cannot log in or who may not log in using the clear text protocol, Telnet uses the secure TTY file to determine whether or not root can log in or may log in on a given terminal. Pseudo terminals do not count unless you're connecting using SSH. So that's a little bit about using Telnet. Let's move on to some other daemons.